Alright, so this is class 20, and just to refresh your memory, we only get through 38 in the semester, so we're more than halfway through, if you can believe that. Seems like we just got started, but in fact we're over the hump, so to speak. Okay, so what's on your plate right now is homework 7 is due Friday, so you now have 48 hours to finish that assignment. I'll give you a little bit of guidance on one of the problems in just a moment. And then the other thing you should be thinking about is the project, which was introduced previously. That cash flow diagram for your life is due on Wednesday, the 21st of April. So I'm going to keep pestering you so you don't lose sight of that. The project will go so much better if you get an early start. And I know everybody's busy and you're juggling a lot of things, but such is life, you know. It's never going to get more simple. Life just gets more complicated when you get a house and a mortgage and a family, a job. So the project. So get an early start is my suggestion. All right. Now on Monday, I told you that today was one of the peaks in terms of difficulty of the semester. External rate of return is probably, it's for sure in the top 3. I don't know if it's the most complicated thing I'll share with you this semester, but it's in the top 3. So I'm glad that you're here, and it's really important you pay special attention for today's class meeting. So before we get into external rate of return, I just want to give you a little bit of help on homework problem number 1. I've received a couple of email questions about this that make me pretty confident people aren't recognizing how simple this first problem actually is. It's much easier than you might expect. So let me give you a moment. If you haven't already read this problem statement, shame on you, but let me give you a moment to read that and think about what I'm asking. All right. How much interest do you expect to receive each time if the bonds pay out on a semi-annual basis? Now, the first thing I want to say about this, not every piece of information that people give you is important. And boy, will that ever be true when you begin working professionally. If you interact with clients, they're going to tell you all sorts of irrelevant information that actually doesn't apply. And you just have to get some practice learning how to filter out what's important with what's irrelevant. And so in this problem, one of the pieces of data that I've given you, you don't need to actually solve the answer. And so the first thing I wanted to say is don't be lured into thinking that, oh, I just need to identify the variables and plug it into some equation. You know, that's not how you solve every problem that you're going to face. Sometimes it's just easier and more direct to read carefully, reason through it, use your logic, and don't just look for an equation to start substituting numbers into. Okay, so something in there is irrelevant. I don't want to take all of the mystery out of this, but I'll leave it at that. The next comment I wanted to tell you is that bonds pay interest on the coupon rate, not on the yield rate. And so in this problem, I haven't told you the yield rate, and you don't need to calculate it. You can't calculate it. There's no basis for you to calculate the yield rate. So you have the coupon rate that you need in order to calculate the interest amount. And then the final bit of advice I wanted to share is the interest amount per period. The formula for that, interest amount, is interest rate times the principal. This, I think I shared that formula with you on the first day of class. That interest amount is interest rate per period multiplied by principal, how much you put into the investment at the beginning. All right, so with that said, I'll just move on, but remember that I'm happy to help you if you've got questions on the assignment. The best way to get in touch is give me a call on Teams. I also can be reached by email or telephone. Less good is trying to chat with me on Teams. You know, the chat functionality in Teams, it doesn't trigger alerts that I see as readily as email and calls from Teams. All right. Now, just to review what we did last time, we went over the IRR, internal rate of return. And so let's just briefly revisit how to do the internal rate of return with this example problem and use Microsoft Excel. So I'm going to paste this example problem into an Excel spreadsheet, and what we'll do is we'll translate that word statement that we were just given. You know, we're given some written description of the scenario, and we'll translate that into what we need to calculate the internal rate of return. All right, so internal rate of return, we're going to define the interest rate. In fact, that's what we're calculating for through goal-seek. So maybe we'll start off with a guess. So, initially a guess and then iterate over time. So initially a guess, then change. All right, so maybe it's 1%. Okay, and then we have year, amount, PV of amount. And remember, the definition of internal rate of return is it's the interest rate that brings equilibrium between the inflow and the outflows. And so there's a balance between in and the out, meaning that the sum of the present worths is equal to 0. All right, so in this statement it says that there's going to be some costs for each of the next 6 years, and then at the end of 6 years it will be sold. So our time horizon is from 0 down through year 6. Okay, now the amount that we have to pay to buy it, minus $345,000. And then we have $98,000 of net revenue, because it generates 120 in revenue, so equals 120,000 minus the 22,000 in costs. A lot of people joining late today. That's really distracting, and I would much prefer it if you join class on time. All right, so I need an extra 0 there. 120,000 minus 22,000 means it's 98,000 in net revenue for each year, except in the last we also have the sale price of the equipment of 115. So for this last year, I'm also adding 115,000. Okay, so we have some cash flow table, and then I'm just going to format these as currency. Okay, now the formula to calculate we want to find out what interest rate gives us the sum of the present worths equal to 0. So we have to use the PV function. Start with this guess rate, the n, skip over the payment field, and minus the amount in the future value field, and then drag that down. And then finally we want to know the total, and add that all up. Okay, so at 1% we have a positive present worth, which means that that's not the rate of return that brings it to a balance between the inflow and the outflows. And from the figure I showed you last time, this conceptual figure is very important, that if you discount with an interest rate that's too low, that would give you a positive present worth. And if you discount with an interest rate that's too high, that will give you a negative present worth. So for instance, what if our interest rate was 40%? It's negative. So what we're going to do with goal-seek, data, what if analysis, goal-seek, is we want to have this total equal to a value of 0 by changing the interest rate. And when we tell it OK, Excel's going to start playing around with all those interest rates, and it'll stop when it finds one that makes the total equal to 0. Okay, so in just moments we find out that the rate of return, I must have typed something in. I wonder if I typed in something wrong. Each of the new 6 years. No? Okay. So this is the method of internal rate of return. And remember that there's also the function, built-in function into Excel, the IRR function. And so if we want to use that, equals IRR, then we would just highlight the values and get that same 22.03%. Okay. Now, the assumption of internal rate of return analysis is that the profits are going to be reinvested into the same project or a project that yields the same return. Sometimes that assumption isn't valid. and by the way, let's talk about decision criteria. If our MAR is 20%, should the equipment be purchased? So yes, it should, because your minimum is 20. This yields 22%, so we should do this project. This project would get a thumbs up on the initial screening. All right, sorry to hear about your Wi-Fi. If you do miss out on a section of the class, then of course the video will be posted on YouTube later. All right, let's look at art for a moment. Anybody take an art history class in high school or here at Marshall? I took an art class in middle school, and I remember we went through all of the great painters of the 19th and 20th century, and what I learned from that is I don't have much of an aptitude for art appreciation. You know, for instance, the picture that we are looking at right now, it's a Gauguin, and it's called When Will You Marry? And it looks pretty ordinary. I mean, to me, this looks like the sort of painting you might pick up at a, I don't know, Goodwill or something, or a Dollar General. And not a big city Goodwill either. But my eye is wrong, because this painting sold in February 2015 for $300 million. And so there is definitely a big market and a big demand for this painting if people are willing to pay $300 million for it. The interesting thing is that its original sales price was only $750,000. So if we consider the effect of inflation, 750 back in 1893 is equivalent to about $20,000 in today's terms. So that original purchaser paid $20,000, and then I don't think it was the same person who bought it in 1893 and sold it in 2015. But let's just ask ourselves, could we calculate a rate of return? And maybe, but what we couldn't do is we couldn't calculate the internal rate of return. I mean, if we put the numbers into a spreadsheet, we would get an interest rate, but it wouldn't apply, because remember, the assumption of the internal rate of return, it assumes that you're going to reinvest your profits. And so the IRR that we were talking about previously, how do we use that analysis? You can use the IRR to compare a project against the minimum. And so that's the initial screening. You can use it to give a project a potential thumbs up or a thumbs down, but you can't use internal rate of return to pick the best project among alternatives, for a reason that I'll show you in a later class meeting. But more importantly for today's discussion is that the internal rate of return assumes that cash flows are reinvested into the project. And so an example of something you can reinvest would be a savings account. Each month when your bank pays you interest on a savings account, the default thing is that the money stays in the account. So next month you're earning interest on what you had before, as well as this month's interest. And so internal rate of return assumes compounding internal to the investment. But there are some things that you can't reinvest. For instance, if you've bought a rare painting and then you sell it, you can't take those profits and reinvest it back into the same painting, because somebody else owns it now. So by definition, you can't reinvest at the same rate. You know, the same might be true if you were starting your own business. Let's say that you are going to buy a food truck, and you want to determine the rate of return of the project. The rate of return, you can only calculate the internal rate of return if you could take the profits you're earning from the food truck and reinvest them back into the food truck. So, you know, for instance, this month, if you take your profits and you upgrade some piece of kitchen equipment, then that would be reinvesting into your food truck. But if you take the money and put it somewhere else, like into a savings account, or if you buy some bonds with your profits, then you can no longer calculate the internal rate of return, and you'd have to analyze the opportunity a different way. So that different way is the external rate of return. That's what we're going to be talking about today. That is where you take your revenue and profits from a project and you invest it somewhere else. So the painting Maybe you take your profits and you put it into a savings account, or you take your profits and put it into buying stocks, or take your painting profits and put it into an ice cream stand. Whatever it is, if you're putting the money somewhere else, then you should calculate the external rate of return. So let's talk about that. It uses an external reinvestment interest rate, I sub I. Now, here's one of the reasons why today's topic is so complicated. I told you that students typically struggle with this. Not all. I mean, I'd say, you know, in our next exam, probably a third of the class will get the external rate of return problem wrong on the exam. Half to 2/3 will get it right, probably. But a lot of people will get it wrong. And part of the reason why it's a little bit confusing is the abbreviation ERR, external rate of return. That's the same abbreviation for external reinvestment rate. So sometimes people get those two things confused, and those are two different things. The external reinvestment rate is when you're taking the money and putting it somewhere else, it's the rate that you earn in that other location. So you're generating cash from your business, you sweep that excess cash into a savings account, it would be the savings account interest rate that is your external reinvestment interest rate. So it's important that you learn the difference between all of the variables that I'm going to introduce today. So I sub I is that rate that your profits are earning. So here's the method to calculate the external rate of return. You're going to put together a cash flow diagram, and from that prepare a cash flow table. You've done that. Cash flow table. Year amount, right? All of the net outflows, so anytime you pay money, those outflows in the future are discounted to times 0, and the rate that you use is I sub I. So you're using the external reinvestment rate to discount outflows to the present. Then you take the net inflows to the future. You compound them to the future at the rate of I sub I. So you're going to find the future worth of the inflows. And then the external rate of return is the unknown interest rate that you're going to be solving for that brings equilibrium between the inflows and the outflows. And so graphically, let me show you how I would summarize this method. I would say you start off with a cash flow diagram. So here's just a schematic cash flow diagram where we have an initial purchase and then some revenue and then another outflow, maybe for refurbishing. Now this year where you've got both an inflow and an outflow, you need to be very careful about this. Okay, warning sign. Warning, warning. If you've got an inflow and an outflow, find the net amount. So don't take the outflow to the present and the inflow to the future. Find the net difference, and if it looks like it's going to be an inflow, then take that to the future. Okay, so you start off with your cash flow diagram, and all of the outflows were taken to P, all of the inflows were taken to F, and the rate that you did for the compounding and discounting is I sub I, the external reinvestment rate. So hopefully so far you're thinking, oh, this is pretty easy. I don't know why he's going on and on about how complicated it is. Because we're halfway there. I mean, if you're following me so far, I think you're going to make it. All right, so this warning. If there's both an inflow and an outflow in the same year, only the net amount gets moved either to the future or to the present. All right, so step 3 then is you've got some amount in the future. Discount it to the present, and you're going to play around with, you're going to iterate the external rate of return until the magnitude of the present value is equal to the magnitude of the outflows that are at the present. So you keep changing the interest rate for the external rate of return until the inflows and the outflows are equal in magnitude. So in other words, the negative of the outflows is equal to the inflows. Okay? Now, if you want to see the formula I'll show you that in a minute. But the definition of the external rate of return is it's the interest rate that makes the present worth of the future revenues equal to the minus of the present worth of the expenses. So it's a weighted average. I'll let that sink in. I'm dropping knowledge here. The external rate of return is a weighted average. And what it averages is two things. It averages the rate that your project is generating revenue, and then it also takes into account the rate that your revenue is earning when it goes to some external account. So both of those factors are taken into account. You know, some projects generate a lot of cash. Let's say that you're in the drug business, right? So the drug business is really illegal but really profitable. So if you're selling drugs, you're going to earn a huge rate of return. But then when you take those profits and you have to invest it into like a low rate savings account, your overall rate of return would be somewhere in the middle. Okay? So this external rate of return method is a way of factoring both the rate the profits are generated and where you put them after they're generated. Okay, so here's the formula that you can find in your book. Don't feel intimidated by this formula. We'll go through a template file that shows you the procedure in just a moment. But what it is saying is that you take all of the expenses, so E means expenses, so all of the outflows are going to be discounted to the present. So you're doing the P/F to take them to find P given F. So all of these outflows over time are taken to P, and you use the external reinvestment rate, I sub I, and then the revenues are all compounded to the future at I sub I, the external reinvestment rate. And then you solve for I prime, the external rate of return. So this is the value that you iterate in order to take the future value. You can either take the expenses to the future to make it equal to the revenues, or the revenues, which are at the future, back to the past in order to bring equilibrium between the two. All right. Now, let me show you the template file that I've just emailed you at about 11:30. Hopefully you got that email. The template file looks like this. Okay, so I have provided a cash flow table, and this is the net cash flow is provided. I should change this example to make it more interesting. We'll be doing external rate of return. We'll get some additional reinforcement through the homework. So you'll get more interesting examples, but I want to change this one up. All right, so take this cash flow table and put it into the template that I provided. And so the template kind of speaks for itself. You can tell from the column titles what you need to do in each cell. You need to separate out the outflows and the inflows. And so, for instance, if it has a minus sign, that means you're spending money, so that's an outflow. And by the way, if it's an outflow, that is already telling you that its magnitude is taken into account. So you don't need to put a minus sign when you type the number into the outflow. We already know that that is a... Okay, did I not send you... Let me pull open the template file that I thought I sent you today. Does the template file look like this? Okay. So here's the template file, and is this the in-class exercise that you printed out? Yeah, I sometimes have different versions of these as I've adjusted them over time. All right. let's use this one. It's more interesting. I guess you know how I was saying I thought this cash flow diagram was too boring? Seems like I came to the same conclusion some other semester. And so I may have not yet updated the in-class exercise file to reflect that. But let's use this cash flow diagram. Since I emailed everybody this one, let's go with this. We want to find the external rate of return for this business opportunity. So we're making an investment at time 0, and then there's a couple of other outflows over time that we're going to have, and some of them are standalone outflows without any inflow that year, and then sometimes there's also an inflow that year. So let's go with this one rather than the boring cash flow diagram on this. I'm going to close that so we don't refer to it anymore. All right, so here's what we're going to do. Fill in the year, and then I think you remember why we do this years until year 13. You know, the reverse time column is what we access for n whenever we are trying to calculate a future value. And you'll notice over here on the right side of the table we have the future worth of the inflows. So we're going to use this secondary time column for when we want to calculate the FV of the inflows. All right, now the external reinvestment rate, hold on just one second. Give me one moment, please. Okay. Well, let's use an external reinvestment rate of 5%, so 0.05. I don't yet have a solution worked up for that, but we'll all use the same external reinvestment rate and we'll see what we get together. All right, so I'm going to pause for a second, and what I'd like you to do is fill in the year column, fill in this reverse time column where we want to know how many years is it to get to year 13, and then type in the amount and differentiate between the outflows and the inflows. And I guess I ought to make this distinction. It's the net outflow and the net inflow. Because remember, when there's an amount in both years, then you need to make sure that, that you've just got the net. So year 5 and year 11, you find the net, whether it's a net inflow or a net outflow. So fill in these columns and then find the PV of the outflows. And so you'll have this outflow column and you find the PV where you're discounting at the external reinvestment rate. And then you calculate the future worth of the inflows at the external reinvestment rate. And then down here at the bottom, 5.5%. Okay. Let's do 5.5%. All right. So let me pause for a second, give you a chance to start filling in the table. Okay, if you're working, you can continue, but if you're stuck on a certain thing, I'm going to start filling in some values here, and so I'll do it without narrating. I'll just start typing stuff in, and if you'd like to watch, then you can. you. All right. So what we have so far is the separation between the inflows and the outflows. And the reason why is that we're going to take anything on the bottom half of the cash flow diagram, any outflow that gets discounted to the present. And then anything on the top part of the cash flow diagram, any net inflow will be compounded to the future. So I'm going to do that in columns F and G now. So in column F, I'm going to do the PV function. So I'm going to calculate the present value, and the rate that I'm using is the external reinvestment rate. That's the place where you put your profits once they're generated. Maybe that savings account or something. So anchor the reference to the rate. The N will be whichever row we're on, because it's going to go back to time 0. Skip over the payment field because we're treating each one of these amounts as a single lump sum future value. All right, so 11,500 is the same since it hasn't moved any years through time. But the 5,400 is discounted to effectively 33.35. And so then I can add up all of that with the sum function. And we have a certain lump sum that's at the present. So if we go back to this conceptual representation of what we've done so far, is we've taken any cash flow amounts that are outflows, they've been discounted to the present. And the next step we're going to do is compound any inflows to be a single lump sum in the future. We don't have to have a minus sign because by definition outflow tells us the direction. And so an outflow is by definition known to be like a negative cash flow. So we don't have to put the minus sign there. All right, now for the future values, we'll do the similar thing. Use the FV function, refer to the interest rate. This time the N isn't going to be year. We want to know how many years into the future it should be compounded. So that's where we're going to use this reverse time column. Skip over the payment field, and it's the minus of the amount into the PV field. So this time we are doing the inflows. Okay. And drag that down through all of them, and what we'll see is that 7,800 already in year 13 is the same as 7,800. So it hasn't been affected since it's already in the future. But all these other amounts, the further away they are from the future, the more they're worth, because they will have compounded more times at that 5.5% rate. Okay, so we add it up. Oh, I accidentally pushed a period at the end there. All right. Okay, so we know the outflows and the inflows. Now, the external rate of return is something that we're going to start with a guess. So it says here initially a guess, then use goal seek. So let's just use 1% as my starting guess. Now what I'm going to do is I'm going to find what is the PV of this. And so down here in this cell, I'm going to do the PV function. And I'm doing it on the sum of the future value of the inflows. So in words, I could call this This is the sum of the future value of the inflows. All right, so down here, I'm going to do the PV of the sum of the future worth of the inflows. That's a complicated statement, right? The present value of the sum of the future value of the inflows. That's 4 ofs in a row. But let's do it. Equals PV. Now the rate I'm using is the external rate of return, I prime. N is 13 years. Skip over the payment field, and the amount that is at the future that I'm discounting, you do the minus sign because of the reason you already know. We'll put this is the F value, the future value. We want to take it to the present. Okay, so if you discount 95,000, which is in year 13, take it back through time, and each year it's losing 1% of its value. By the time it gets to time 0, it's worth 83,000. We want to know what interest rate makes it so this is equal to that. So what interest rate makes it so that the sum of the present value of the sum of the future value of the inflows is equal to the sum of the present value of the outflows? So is it 2%? We're getting closer. What about 3%? Oh, I typed in 0.03. Getting closer. So we can do goal seek here. Data, what if analysis, goal seek. And our goal, we want this to be equal to 14,835.20. That's our goal, is for this cell, which represents the discounted accumulated future worth of the inflows. So we're taking it from the future to the present. Remember, graphically, what that looks like is we've added all of this together in the future, and we're going to discount it at the external rate of return to find it until the magnitude is the same. So we're looking for the magnitude to be equal to 14,835 by changing the interest rate. Okay, let me pause for a second and let you look at what's in the goal seek there. Click OK, and it'll calculate the external rate of return is 15.37%. Anybody else get 15.37%? Good. Okay. Excellent. Okay, well there you have it. External rate of return. It's in the top 3 of most complicated things I'll teach you this semester. You got through it. How will you remember it though? You know, how do you remember something complicated like that? Can you just see it one time and then still remember it by Friday, April 30th, which is when we're having our final exam? Probably the best way is practice. You know, if you delete all this and you go through the method again with the same data set, you know, if you clear out, I sent you this template file, delete everything, well, maybe copy it to a separate sheet, you know, so here's the solution. If you want to create a copy, move or copy, let's create a copy, and so I'll call this one practice again. Okay, so practice again, and that practice is what's going to make you remember. Ronnie wonders if maybe we're going to get a homework problem on this soon. Ronnie's got the right idea. That's going to be another opportunity to practice. Let me show you that I think you do have a problem that's due on Friday. Let me bring up the homework assignment and just double check that I've given you an opportunity to practice your newfound knowledge. You now know how to do an external rate of return. Like, this is the sort of thing that you should impress your parents with. They're spending all this money and supporting you to go to college. Somebody is. Maybe you're supporting yourself, but you need to get a little bit of clout for these complicated things that you've learned how to calculate. You know how to do an external rate of return analysis, and most people, even a lot of money people, don't know how to do an external rate of return analysis. So on homework 7, did I give you one? There it is, problem 9, in all its glory. Determine the external rate of return. Okay. Any questions about this procedure before we part ways for today? Alex was wondering if I could show the answer again. Yes. Let me bring that up. Any other questions? Watch the YouTube videos repeatedly. I was just scrolling back through some of the other comments. That sounds like a recipe. It's the cure for insomnia. Going back through these YouTube videos a second time. All right, well that's it for today, everybody.
I have a question.
Please go ahead.
Can you show the command? Can you show the command you put for the external rate of return again?
The what?
I blinked for a second. The command for external rate of return that you put in the yellow box.
The yellow box, it's a number. And so, yeah, so you start off with a guess value, and then what we do is we do the goal seek from there. And so the key to find that value is data, what if analysis, goal seek. So for that, we want this to be equal to, and we have to just manually type in the amount that we're looking for, 14,835 and 20 cents by changing what's in the yellow cell. So the yellow cell isn't a formula, it's a number, and then through goal seek, Excel will iterate many different times and then find the correct interest rate that that gives you balance here versus there.
All right, thank you.
You're welcome. All right, well, take care, everybody. Thanks again. Hope you have a good one. Go enjoy some of this nice weather, all right?